Hi guys, me in this Mego shirt, I'm Vinay. So today I have something for you. Yeah, it's actually a police siren. Yeah, and this circuit is based upon two 555 timers. So here I can turn this on for you, and here is my RPS. And I think you know what an RPS is. An RPS stands for the regulated power supply. Here I have four ports. They are the plus 5 volt port, 9 volt port, 12 and 15 volt port. Now I am going to turn this on, and I guess I can hear this sound, and this is very similar to the police siren which you have all heard. The near this sound, yeah, it's nice. So here I have two adjustments, like I have two potentiometers. This is the potentiometer number 1 and this is the potentiometer number 2. So here using the potentiometer number 1, I can adjust the time interval between the rise and fall of this sound. Here's a demo. Yeah, just look at this. Yeah, when I turn this, the time interval between the waxing and waning of the sound changed. I mean it decreased. So if I turn it back, I can get the sound which I had before. And here using the potentiometer number 2, I can actually change the basic frequency. Yeah, see how beautiful it is. Now its frequency is going dangerously high, and I can go on decreasing it again. I can come back to the frequency from where I began with. Yeah, it's awesome, right? So here I have two 555 timers. I mean the 555 timer IC. This 555 timer IC is an 8-pin IC. So here I have used the timer IC number 1 and number 2. And also before interfacing the circuit to a loudspeaker, and this loudspeaker is a 4 ohm speaker, and before interfacing that you need to use a transistor to amplify the signal. And I have used an SL100 transistor over here. You can just have a look at this. Yeah, this small thing is the SL100 transistor, and here I have a few capacitors and all. Yeah, you can take a look at all this. I mean at this circuit, in the circuit diagram which I am going to attach in this video itself. Now let's take a look at the waveform which we get at the speaker input. So here I have an oscilloscope software on my PC, and this is called the VA, the Visual Analyzer 2011. And this software is completely free of cost. It's freeware, so anyone can download this and use it. So here is my probe, a small circuit. So here actually I have connected this to the line in port of the sound card of my PC. So here I have two probes, the positive one and the negative one. And this small circuit is the attenuator circuit, because the computer sound card works only when the input works well, or it's safe to work with, at a voltage level of 0.7 volts. So here I do the same thing. These diodes do the same thing and clip the input voltage level to a value of 0.7 volts. So now let me connect this. I'm going to connect the negative part to the ground point of the circuit. The ground point of the circuit. I'm connecting this, and the positive one to the positive point of the loudspeaker. Now let me do this. I'm sorry for the disturbance. Yeah, now just take a look at the waveforms coming on the screen. Yeah, it's awesome, right? Yeah, now I will increase the frequency. Just see what happens. Yes, sir. As you all know, as frequency increases, the time interval goes down, and that's what is happening over here, because the base scale on the x-axis is the time scale. Now I can go on increasing and reaching dangerously high levels. So I can come back again, slowly, and slowly, and now it's back to normal. It's cool, right? And this software offers one more feature, and that's the frequency response feature. On the x-axis, you have the frequency scale beginning from 20 Hz to 19.4 kHz, or almost to nearly 20 kHz. And on the right, the y-axis is the decibel scale over here, this blue scale. Okay, now as I go on increasing the frequency, you can just take a look at the frequency response. The entire graph is shifting towards the right, I mean to the high frequency side, slowly and slowly and slowly. Now when I lower the frequency, once again back to normal level, the entire waveform is slowly shifting to the lower frequency side, I mean to the left. So this is how this whole circuit works. This is cool, ain't it? So I call upon you all, I mean all the viewers who are watching this video to try this circuit. I promise you that this is a very simple circuit, and you must all try this at your home. Okay, thank you, and also for more videos from me. Thank you, bye.
Hi guys, as you can see in this circuit, there is no transistor, which I spoke about in my video. So here, that's because an 8 ohm speaker is used, and I used a 4 ohm speaker. So when you have to use a 4 ohm speaker, it's mandatory, and it's good that you use a transistor at the pin number 3 of the second timer IC, I mean the 555 IC. So there, what I have done is, I have connected the base of SL100, and SL100 is an NPN transistor, to the pin number 3 through a 1 kilo ohm resistor, and the 1 microfarad capacitor which you can see in the circuit was removed, and instead of that I just used a 1 kilo ohm resistor, and it was connected to the base of the transistor, and the collector of the SL100 NPN transistor was connected to the VCC, I mean the 5 volt power supply, and the emitter was connected to the positive of the loudspeaker, and the negative of the loudspeaker was grounded. So these are the changes which you can make to optimize the sound which you get from the speaker. Thank you one and all.